Now that we're armed with an understanding of the typical synovial joint, let's look at specific synovial joints. And we'll do that by looking at the different classifications of synovial joints. We're going to see that there are 6 different types of synovial joints found in the body, and they're classified based upon the shapes of the bones that form the articular surfaces. In this part of the presentation, I want to go over the 6 different types of synovial joints. Again, we'll kind of go over these throughout the semester as we see examples of these different types of joints. But I wanted to go over the 6 types. There basically are 6 types of synovial joints, 2 that move in one plane, 2 that move in 2 planes, and 2 that move in 3 planes. And we often characterize them or classify synovial joints based upon the number of planes of movement that they have. So we'll take a look at the kind of the simpler or the one plane joints, and then move up to the 3 planes. So the first type of joint is a hinge joint. Hinge joint's kind of the easiest to understand. One side of the joint, one bone, has a convex surface. That means rounded, and the other has a concave surface, which is kind of an indentation. So in this picture, the top bone would be the concave, the bottom is convex, and the bottom bone is concave. And then they fit together in a way like a hinge and a door, and they allow motion in one plane. So they are considered to be a uniaxial joint, meaning they have one axis of rotation or one plane of motion, or often they'll say that it has 1 degree of freedom. That means it can move within one plane. Examples of hinge joints are numerous, but the elbow is a hinge joint. So the joint between the ulnar and the humerus is a hinge joint. The finger joints, the interphalangeal joints, are again going to be hinge joints. And then the knee is a hinge joint, although often people will consider that to be a modified hinge joint, which we'll discuss when we get to the knee. Pivot joints also only have one plane of motion. So they have one plane of motion or 1 degree of freedom, and they are structured in a way that allows one bone to pivot or rotate around the other. So one bone has a projection, or again, like an axis that fits into a ring-like projection or ligament of another. And again, they rotate, one rotates upon the other. The atlantoaxial joint, that's the joint between C1 and C2, is a pivot joint. And then the proximal radioulnar joint, the radius rotates on the ulna. And again, that's a pivot joint as well. A condyloid joint is a biaxial joint. It has 2 degrees of freedom, and the bones can move in 2 planes. So in a hinge joint, for instance, we have one plane of motion, potentially flexion and extension most likely. In these types of joints, we often see flexion and extension and abduction and adduction, or some other motion. Basically, condyloid or ellipsoid joints is we have a oval-shaped convex surface of one bone fits on a similarly shaped depression on the other bone. So it still is a kind of a convex-concave relationship, but because one bone is rounded in 2 planes, it allows motion in 2 planes. The radiocarpal joint of the wrist is an example of this type of joint. And again, your wrist can move into flexion and extension, as well as abduction and adduction, which is often called ulnar and radial deviation. The metacarpophalangeal joints of the fingers, that's where the finger joins the hand, allows for flexion and extension, abduction, adduction as well. Saddle joint is found primarily, and most people would say there's one. It's the joint between the trapezium and the first metacarpal at the base of the thumb. It's a biaxial joint, and it has 2 degrees of freedom, so it moves in 2 planes. Basically, one surface is convex in one direction, concave in the other, as is the other. And again, it kind of, they call it a saddle joint because it mimics what it looks like for a rider to sit in the saddle. And it allows basically the rider to slide sideways, left and right, but also move their bum forward and backward in the saddle. So a technical term. But again, that's why it's called the saddle joint, that's what it loosely looks like. Now, the multiaxial joints are going to allow motion in 3 planes. This first classification, a ball and socket joint, does also tend to allow a fairly large range of motion. So ball and socket joints occur in the shoulder between the humerus and the scapula, and at the hip between the femur, the head of the femur, and the acetabulum, which is formed by the pelvic bones. And again, its name really tells you the structure. We have one joint surface that's shaped like a ball. The other surface is shaped like a socket. And again, the ball fits into this cup-like depression. It allows motion in 3 planes. So in the case of the hip and the shoulder, we have flexion and extension, abduction and adduction, and then rotation, which is called internal and external rotation, or medial and lateral rotation. Now, a plane synovial joint, also known as a gliding synovial joint, does allow motion in 3 planes, but often it doesn't have much motion. Even though the motion occurs in 3 planes, there is not necessarily a lot of motion allowed. And it's basically wherever we see 2 flat surfaces come together, and then those bones can slide on one another, and they basically can slide back and forth, left and right, as well as rotate. But the motion typically is fairly small. We see these joints in the wrist between the different carpal bones. We see it in the foot between the different tarsal bones. And again, they're kind of flattish surfaces, and they can move on one another in 3 degrees of motion. All of these are examples of synovial joints. So they all are going to have, again, same structure as all synovial joints, 2 bones, 2 or more bones, covered with articular cartilage, a joint space between them, and then some type of a joint capsule that encases the joint that produces synovial fluid. So again, this graphic, again, is just helpful. It has all 6 of this types of synovial joints on the one slide.